Let's discuss problem number 9.9, standard 12 physics, ray optics. Now we are given that there is a concave lens and an object of height of the object is given as 3 centimeters, which has to be positive because it is above the principal axis. The focal length of the lens is 21 centimeters, which has to be negative because it is opposite to the direction of incident ray. So this would be the direction of incident ray, focal length is in the opposite direction, so as the object distance, which is 14 centimeters, so negative sign. Now if we put the object in this way, then as per the ray diagrams, first ray parallel, and it will go in such a way that it passes on extending backwards, it passes through focus, so like this. Now the another ray directly passes from the optical center in this way. Now since both the refracted rays, they do not meet, so we extend them backwards, so they meet somewhere over here. So we have a virtual and erect image as well as a diminished image. So this image height is hi and we are supposed to find it. Now as per the ray diagrams, we see that the image distance should be negative and hi should be positive. So first of all, let's find out the image distance with the help of the lens formula. So 1 upon f, that is 1 upon v minus 1 upon u. Focal length is of course negative, minus 21. 1 upon v minus of 1 upon, as per the sign convention, it is minus 14 centimeters. So on reciprocating and solving further, we get v is equal to minus 8.4 centimeters. You don't have to plug in v as negative, this has to be obtained. So this negative value of v suggests that the image is on the left hand side of the lens or towards the object. Now if you find the magnification, it has to be positive and less than 1 because the image height is smaller than the object height. So let's find the magnification, that is hi upon ho. Please remember that is equal to v by u, it is not minus v by u, that is in case of the lens, sorry, that is in case of the mirror. These are lenses, so it is plus v by u. Now ideally magnification we don't want, we want the height of the image, so hi upon ho is plus 3, this is minus 8.4 and u is minus 14 centimeters. So if you solve this, you will get the value of height of the image as 1.8 centimeters, which is positive, and which clearly indicates that the height of image is smaller than the height of the object. Now the nature of image, it has to be virtual and direct. Second, it is diminished. Rest everything is being calculated. Now the next part of the question says that if you shift this object even somewhere over here, I mean far away from the lens, what is expected? So now let's draw and verify what is going to happen. Now this is the new position of the object. So first ray again, it has to be parallel to the principal axis and it passes such that it, on extending backwards, it passes through focus. So now it goes like this. Now the second ray is what is going to change. So now from the optical center, it goes in this direction. Now this is your first refracted ray, this is your second refracted ray, both of them, they do not meet, so virtual and direct image. Now on extending backwards, they meet somewhere over here. You can see that this is the first one, this is the second one, and even the height of the image decreases. So if you shift the object backwards, the height of the image keeps on decreasing. On bringing it forward, the height of the image increases, but always remember that the height of the image always remains smaller than the height of the object. Whether you go in this direction, the height of the image slightly increases, but it will stay less than the height of the object always. If you bring it backwards, then the height of the image further decreases.